Hello everyone, in this video we are going to solve the problem number 1.46 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A solid body rotates about a stationary axis according to the law phi is equal to at minus bt cube, where a is equal to 6 radian per second and b is equal to 2 radian per second cube. So let us say we are having the solid body which is rotating about the axis that is passing from this particular point, and for example let us say this is the point A which is making an angle of phi, okay, and this particular phi is given as at minus bt cube, okay, where a is equal to 6 radian per second and b is given as 2 radian per second cube. Okay, so let us substitute the value of a and b in this particular expression. So we will get phi is equal to 6t minus 2t cube. Now in the first part of the problem it is asking to find the mean values of the angular velocity and the angular acceleration averaged over the time interval between t is equal to 0 and the complete stop. First of all we will find out the equation of angular velocity and the angular acceleration in order to see that if the angular acceleration is constant, in that case we can just find out the angular velocity at 2 points and then we can take the average of those 2 points. But if the angular acceleration is not constant and it is dependent upon the time, then in that case we cannot find out the average of the angular velocity just by taking the average at two particular points. Okay, so let us first find out the angular velocity. So angular velocity we can write it as the derivative of the angular displacement with respect to time, that is equal to d by dt of 6t minus 2t cube. So from here we will get 6 minus 6t square. Okay, so this is the equation of angular velocity we got. Now if we talk about the angular acceleration, that we can write it as the derivative of angular velocity with respect to time, that we can write it as d by dt of 6 minus 6t square. Here the differentiation of 6 is 0 minus differentiation of t square is 2t, so here we will get minus 12 into t. So the value of alpha we got, that is minus 2t, and we can clearly see here the angular acceleration depends upon the time. So we cannot use the methodology in which we can just find out the average of the angular velocity between 2 points. Okay, so for that we will use the formula, that is the average velocity of the angular velocity is equal to angular velocity into dt integral from t is equal to 0 to, let us say, t whole divided by dt integral t is equal to 0 to t. Similarly for the average angular acceleration we can write it as alpha into dt integral from t is equal to 0 to t whole divided by dt t is equal to 0 to t. And what is the final time? That it is given that when it is complete stop. Okay, so that we can find out as, let us say, complete stop means when the angular velocity is equal to 0. So what is the expression of angular velocity? That we have got it as 6 minus 6t square. So we can write 6 minus 6t square is equal to 0, and from here we can find t is equal to 1 second. So this is the final time, and initial time is t is equal to 0. Okay, so we will integrate from t is equal to 0 to t is equal to 1 second. Okay, now let us find out the average value of the angular velocity and the angular acceleration. So we can write omega average is equal to omega times dt integral from t is equal to 0 to 1 whole divided by dt from t is equal to 0 to 1. Angular velocity is given as 6 minus 6t square. let us integrate that 6 minus 6t square into dt. Integral from t is equal to 0 to 1 whole divided by dt. Integral from t is equal to 0 to 1. So if we integrate the above expression, then we can get 60 minus 60 cube by 3 from t is equal to 0 to 1 whole divided by integration of 1 is t from t is equal to 0 to 1. So we will get 6 minus 2 whole divided by 1, that is equal to 4 radian per second. So this is the value of average angular velocity we have got. Now coming to the average value of the angular acceleration, that we can write it as alpha average is equal to alpha into dt. Integral from t is equal to 0 to 1 whole divided by dt. T is equal to 0 to 1. What is the expression of alpha that we have found out here? That is minus 12t. Okay, so we can write minus 12t into dt. Integral from t is equal to 0 to 1 whole divided by t from t is equal to 0 to 1. And the integration of minus 12t will be minus 6t square from t is equal to 0 to 1 whole divided by 1. So we will get minus 6 radian per second square, or we can write the magnitude of the average acceleration is equal to 6 radian per second square. Now coming to the second part of the problem, it is asking to find the angular acceleration at the moment when the body stops. When the body is stopping at the time moment of t is equal to 1. So we can write the body is stopping at the time moment of t is equal to 1 second. T is equal to 1 second, and expression of angular acceleration is given as minus 12t. So we can write minus 12t at t is equal to 1 second. We can get it as minus 12 radian per second square, and if we write the magnitude of the acceleration, then we can get 12 radian per second square. Okay, so this is the value of the acceleration, angular acceleration we got at time instant of t is equal to 1 second where the body is stopping, and this is the average acceleration from t is equal to 0 to t is equal to 1 second, and this is the value of average angular velocity from t is equal to 0 to t is equal to 1 second. I hope the entire procedure is clear. Thank you.